Apps and instruments. I'm here today to show you the setup and HI 2300 benchtop connectivity meter. As you can see inside the box, we have the basic meter here, and then the other box you'll find the power supply adapter and the connectivity probe. In my hand is the connectivity probe. As you can see, there's a DIN connector right over here that's plugged into the back of the meter, and at the front end there is a protective plastic insert here that should be removed before the installation onto the meter and before its use. The connectors on the back, you can see, will plug into there, and then there's a part for the power. Now, after setting up the meter, attaching the probe to the back and plugging in the power supply and turning it on, I do have the probe attached to the optional probe holder. That is a separate accessory item. I'd like to show you some of the setup functions within the meter. To access the setup screen, you have to press the Alt key and the setup key at the same time. So from there, we are now entered into the setup mode. Pressing the up and down arrow will go through the options for such as the software version. If you'd like to see 2.7 is our software version. This is for what type of temperature compensation that we'd like to have. Pressing confirm, we can change it from automatic temperature compensation to no temperature compensation to manual temperature compensation. Since I do like automatic temperature compensation, I leave it set on that. The next is the reference temperature that we base on. Most meters are programmed automatically at the 25 degrees Celsius temperature sensor. TDS conversion factor, which again, normally for all connectivity measurements, we take the measurement, multiply it by 0.5, and we convert to TDS. Some applications require 0.65 or 0.68. The meter gives you the option to make those adjustments. The cell constant, the default value is 1.0. After calibration, you will get an adjustment with that based on the standardization of the electrode. Auto off, if we like to have it so either the meter turns itself off, or we can have it on where it turns off after I believe it might be 10-20 minutes. I'd have to check the manual to confirm, but I like having set off as default. The same thing for the beep. If we like to hear the beep turn on or off, we can do that as well. The year set for 2010, the date set for today, August 20th, and then the time set for 1:44. That's the time of the day right now. We have the instrument ID number. If we had multiple meters within a certain plant and we are using the logging function of the meter and we're transferring data into a computer, this would be used to be able to identify one particular meter that you're taking this information from. After that, that's pretty much the setup options that we have available. Hit Alt Setup, and now that we escape out of it. The next part we'd like to do is a calibration. I do have some standards here, 12.88 and 1413 microsiemens solution, and a bottle of fresh 84 microsiemens solution as well. If you are going from a higher range to a lower range, it is very important that we rinse off any of the higher salt solution off the probe, so we do not contaminate this other solution with it and make it a higher value than it actually is. The probe should be rinsed out from the outside, and there is a little fill hole right up here at the top, and we can actually push some water inside there to make sure nothing's on the inside. It is also very important that when we do any kind of calibrations or measurements that the amount of solution that we're measuring is past the fill hole and there are no air bubbles trapped inside there. I'm going to take the probe now and place it in the 1413 microsiemens solution and do a calibration. Since the meter is an auto calibration meter, it will automatically go into the range at the highest value selected for it. And again, make sure that there's no air bubbles trapped inside there. As you can see, the reading jumped just a little bit just because of a little bit of air trapped with inside the probe. Now all we do is we press the calibration button. It is prompting for the 1413 microsiemens solution since it knows it's going to be close to that value. Once it stabilizes and it recognizes that value, CFM will show on the display. At that time, we will hit the CFM button to confirm that value. So right now it's flashing CFM. I hit confirm. Tell me the calibration is good, it's accepted within a certain tolerance, and now the meter is calibrated using the 1413 solution. I am going to test my 1413 that I placed, or the 84 microsiemens solution that was placed in the beaker after I rinse it with a probe, and I will absolutely make sure that I will not contaminate that with either the water or the 1413 since it can affect the value. Alright, now the probe is placed in the 84 microsiemens solution. The accuracy of the instrument is 1% of that value, which means at 84 microsiemens I would expect at least it can be up to an 8.4 difference. And I will show you just by lowering this down into the solution, we can actually change the value a little bit just by doing that because of getting around the rings. So again, it is important that there are no air bubbles within the electrode to get the accurate measurement. It is still a little bit higher, and that could be due just again to a little bit of the drag out that I didn't really rinse it out well enough with the solution going on the inside of the probe after coming into the 1413, giving me a slightly higher value. Again, these are two different standards I would use based on an application. If I'm going to be measuring water, high purity water, reverse osmosis, the lower range conductivity measurements, I should be calibrating in the 84 microsiemens solution. And I can tell the meter that, hey, this is 84 microsiemens solution by simply pressing the cal button. It's prompted me for 84 microsiemens solution. After it sees a stable measurement, it will lock on that measurement and we will hit confirm again. Again, I will press the confirm button, and now I just told it that it's 84 microsiemen, and there is a chance that that is not truly an 84 microsiemen just by the contamination within the probes, but it is going to be relatively very close. This shows again the basic calibration procedure for our HI 2300 auto ranging connectivity meter. There are some other features to it. Again, if we hit the range button, that will show us the reading as in TDS. And then again is percent sodium chloride, which is based on Atlantic seawater. And then back to connectivity. So thank you for taking the time and watch this. And if you have any questions, please let us know.